Jonathan from Rain Brothers here, rainbrothers.com. Today we're going to go through step by step how to install our low yield well reservoir system. This is the perfect system if you have a well that only has a recharge rate of even as low as half gallon a minute. You can really improve your whole household water supply by adding a reservoir. And the concept behind it is that instead of drawing directly from your well, you're instead putting your well into a tank so that it can feed the tank throughout the day. Even if it's a trickle, occasional trickle, it will feed this tank, fill the tank throughout the day, and then you're drawing from the tank instead of directly on the well. A standard well system is going to have several basic components. First, you're going to have your pressure tank, and this is generally located in a basement or utility room. You have your water line feed coming directly from your well. If you have a basement, it's going to come through the basement wall, or if you're built on slab, it's going to come up through the slab floor generally. This blue line is the direct feed from the well. You're probably going to have a wire that's attached to that supply line. This is likely going to be the wire that's powering your well pump. It goes to a pressure switch. This is what turns the well pump on and off based on the pressure in the system. Then on the other side of your tank tee, you're likely going to have a feed that goes to your house supply. So this is going to be your cold water supply to the house. This generally goes straight to a hot water tank. It branches to a hot water tank, and then another branch to your cold water line feeds throughout the house. It could go to a PEX manifold system, but this should be apparent which one is feeding the house. Then you have a wire that is coming from your breaker panel that's going to supply power to the pressure switch and then in turn to the pump in the well. So before we begin, we want to identify the parts on this well system so that we know what we're getting into. Now, it's very important to know a couple things when you're setting up your reservoir system. You're going to want to know what the horsepower of your well pump is, and you're also going to want to know what the voltage of your well pump is. And the reason for that is that we need to install our little fuse pump saver. We're going to put this on the well pump as we install this well reservoir system. And this pump saver needs to correspond with the voltage of your well pump as well as the horsepower. Our basic model is good for a pump up to 1.5 horsepower. Anything more than that, we need to add a few other controls to the system because there's a lot more current going through the cabling. So if you can, try to find the paperwork for your well pump. Make sure that it's under 1.5 horsepower. If it's over, no problem. We just need to know that. And then also the voltage of your pump. The easiest way to check the voltage of your well pump is to simply look in your breaker panel. If the breaker that supplies power to this pressure switch is taking up 2 slots in the panel, that's a 230 volt breaker. If it's only taking up 1 slot, it's a 115 volt pump. The other way you can check the voltage of your well pump is with the power on and being very careful to remove the cover. You would take a multimeter and find the lead that is coming from your breaker panel, and you're going to take a voltage reading. You wouldn't want to touch it. This is not connected to power, but with your multimeter, you're going to measure voltage with one probe here and another probe here, and that should give you either 230 volts or 115 volts, depending on the power supplying your pump. The other thing we're going to want to note before we start cutting into our plumbing here is the pipe type and size going into the pressure tank and out of the pressure tank. In this case, we have 1 inch. This is called iron pipe size poly well pipe. This is a pipe type that fits over a barbed fitting and is clamped on with 2 hose clamps. That's a telltale sign that you're working with iron pipe size poly pipe. We know it's 1 inch because there is printing on the pipe that says as much. So we're going to need an adapter for that. We're going to carry this water line to our reservoir tank. So we're going to cut this pipe and adapt it and plumb it to the tank, directly to the tank. There are several components that come with our low yield well reservoir kit. There is 3 pipe penetration gaskets. These are going to be used to run our pipe through the tank wall in a watertight fashion. We have a normally closed float switch. This is what is going to turn the well on and off based on the water level in the tank. So in the downward position, there's a closed circuit, so it's going to keep the pump on. And then as it flips upwards, there's a click, and that's going to open the circuit to turn the pump off. So when the tank fills, the well pump knows that the tank is full and shuts off. Then we have a cable weight. This is what's going to tether the float switch inside the tank. We have our little fuse pump saver. This is a device that detects the amperage draw on your well pump. You're going to calibrate the pump saver when you're sure that there's water in the well, and it's going to read that amperage draw under the load of water. If this device detects a drop in amperage, that means the pump is doing less work, which means it's drawing air, and it's going to automatically shut the pump down, and it will keep it off for a preset amount of time, after which it will cycle again and see if there's water in the well to fill the tank. So this is the pump saver. Then we have our Springer Series half horsepower traditional pump. This is what's going to go inside the reservoir tank to supply water back to your house. For the holding tank itself, we use our freestanding Norwesco tanks. Generally, you want at least 250 gallon, but you probably don't need more than 500 gallon for a reservoir system. These tanks are nice because they are designed to fit through doorways, but as you can see, they are rather long. So if you're trying to place it in a basement and have to get through a landing on a stairway, then you may want to just check our dimensions on the website to make sure that this length will be copacetic for that turn on the stairway. We have great prices on these tanks. We'd love to help you out there as well. When you're placing the reservoir tank, you want to have it in proximity to your pressure tank, and you also want to place it in an area where you hopefully have a floor drain, so we can run an overflow out of this tank to a floor drain. If you don't have a floor drain, no worries. We do have an alternative system for controlling overflow to prevent potential flooding, and we'll go over that later. So the first thing we're going to do is mark out the locations for our pipe penetrations into the reservoir tank. As you can see, we do have 3 1-inch gaskets that come with the kit. So what we're going to do is we're going to cut this well line and run it into the top of the well reservoir tank. So I'm going to make a mark on this reservoir tank where I want to drill a hole. The second thing we're going to do is we're going to put a pump inside the reservoir tank, and that pump is going to have a supply line that now comes out and over, and instead of this well being plumbed directly to the pressure tank, instead we're going to cut this part out, and that supply line coming from the submersible pump in the tank is going to now supply the pressure tank. So that line is going to come up and over, so we're going to drill a second hole right here, right beside it, coming out the top. And then this third hole is, or the third gasket rather, is for our electrical penetration if we want to run 1-inch conduit through the lid. You don't have to use this one, but we include it just in case. So I have 2 holes marked. I'm going to get my hole saw, and these 1-inch pipe penetration gaskets use a 1 3/4 hole saw. We're going to make sure our centering bit is nice and tight, and that the hole saw itself is nice and tight. And we're just going to drill right on this mark. Okay, so we have our 2 holes drilled, and it helps to have a pocket knife handy to deburr the edge of the hole. And then we're simply going to insert these gaskets right into the hole. You kind of have to pinch them a little bit to get them in there. The flange part is going to be on the outside of the tank. And these are, again, 1-inch gaskets, but here's a trick to these gaskets that confuses a lot of folks. It's best to use 1-inch PVC to go through these gaskets. Not CPVC, but regular Schedule 40 or Schedule 80 1-inch PVC. Because if you use 1-inch CPVC or 1-inch PEX, it's actually not the same 1-inch size as PVC, which is iron pipe size. You can see that these are both 1-inch pipes. This is 1-inch PEX, this is 1-inch Schedule 40 PVC, this is iron pipe size, and this is copper tubing size. So the 1-inch pipe size is different, even though they're both classified as 1-inch pipe. Very confusing, but if you put the 1-inch PEX through the gasket, yes, it'll be tight, but it won't be watertight. If you want this gasket to be watertight like it's supposed to, you want to use 1-inch PVC, which will not be easy to get through the gasket. You'll have to maybe file it down a little bit. But once you push that through, it flares out the backside of this gasket to create a watertight seal from inside out. Now that we have our holes drilled in the tank, our next step is going to be to disconnect the well pump power from this pressure switch. To do that, we want to make sure that the breaker is turned off for the well pump. We're going to undo the lid for the pressure switch. If you have a voltage tester, now would be a good time to use it to make sure that there's no power going to this pressure switch. We're going to locate the wire that is coming from the well pump. In this case, it's right here. And we're going to disconnect that wire only. Okay, this cable is being removed completely from the pressure switch. The other side we're going to leave in place. That's the power coming from the breaker panel to the pressure switch. We're going to leave that in place. Next, we're going to cut any tape or zip ties that are connecting the wire to the well line. And then we're going to remove this water line from the pressure tank T. Since this is poly pipe, we're not going to use that coming out of the new pump, so we want to remove all this poly pipe so that we have an opening on the tank T to plumb in. So we can cut it back here. Of course, you want to make sure that the pressure in the system is drained out. You'll shut off the main supply line in the house and drain out the tank T by a drain valve on the front. Make sure there's no pressure in the line, and then cut into it. Then again, if this is a different type of pipe than we're using to supply the new water line, we're going to unthread this fitting from the tank T. Now that we have that removed, we're going to leave this open for the new pump. And then, assuming that this is fixed, since this is still connected to the water line that goes out to the well, we're going to adapt this poly pipe to Schedule 40 PVC so that we can run it into the top of the reservoir tank. To adapt 1-inch poly to Schedule 40 PVC, there's a couple different methods of doing it. We have a barbed adapter on one side. This is what's going to insert into the poly pipe. Then on this particular way, there's 1-inch male threads that we would thread into a 1-inch female PVC adapter. So we would wrap this with Teflon tape, wrap the threads, and then thread this together. Now there's always a risk when you're threading metal male into plastic female, you can overly tighten the metal threads and it can crack the female. So it's better to adapt it in this manner. Use a 1-inch barbed by female adapter for the poly, and then wrap this side in Teflon tape and run your 1-inch PVC into the female adapter. So that's what we'll do here. We're gonna just grab our Teflon tape, wrap it, and then thread this together. Hand tighten and then use 2 pipe wrenches to thread it together. On getting this plumbed into the poly pipe, all we're going to do is we're going to use 2 hose clamps. We're going to heat up the poly pipe with a torch to soften the poly. Helps to have a mallet nearby, and then we're just going to insert this brass fitting into the softened poly. Just like that. We'll use a 5/16 hex head drill to tighten 2 hose clamps onto there. Now we're set up to glue our PVC into here and run it into the top of the tank. We're going to run our well line into the far side here, this far side fitting. So I'm just going to cut a short piece of 1-inch PVC. Now here you can use Schedule 40, you can use Schedule 80 PVC, doesn't matter, they have the same outside diameter. There's no real reason to use Schedule 80. Schedule 40 is just fine. We're just going to cut a short piece, then it helps to file this down and lubricate it with some dish soap. But all we're going to do is pop that in there, grab a rubber mallet, and tap it through. Now you want to make sure the pipe goes through the gasket, and don't get it too far because you cannot pull the pipe back out. You have to, if you do that, you have to hit it from the inside, pop the whole gasket out. It doesn't work real well. But as you can see, that's a very tight fit on that PVC pipe, nice and watertight connection. Now at this point we are going to use some PVC primer, prime both the sides, PVC cement, to glue this on, but I'm going to dry fit it for now. This is just a demo installation. So we're going to turn it 90 degrees. We're going to ultimately connect to this water line fitting. So then we'll get another short piece of PVC right here and put that in with a 90-degree fitting going up, and we'll connect all this here. That completes our well feed to the reservoir tank. And again, of course, if we were doing this for real, we would PVC prime and cement all joints to make sure they're watertight, because this is a pressurized fitting. Now, we're going to plumb in our Springer Series traditional submersible cistern pump inside this reservoir tank. Now, there's a few things to note about which pump to select for the reservoir tank. It's real tempting to match the voltage of your well pump, and in some cases that makes perfect sense to do. But technically, the well pump and the reservoir tank pump need to be on separate circuits. You shouldn't share a breaker if you're trying to follow electrical code. So it doesn't have to match the voltage of the well pump. And especially you want to look at your electrical panel, and if you don't have a lot of empty slots in the electrical panel, a 230 volt motor will take up 2 slots in that panel, whereas a 115 volt motor will only take up 1 slot. So you want to look at your electrical panel, see what you have room for, and use that as a guiding principle to select the voltage for the reservoir tank pump. Now, we're ultimately going to wire this pump to this pressure switch right here. So if you have room in your electrical panel, let's say your old well pump was 230 volts, this is already going to be 230 volts going to this pressure switch. You may want a 230 volt pump for this reservoir tank. But again, if you only have 1 slot open in your panel, you're going to want to switch this over to 115 volt by switching out the breaker in the panel and then selecting a 115 volt pump for the reservoir tank. Now in this case, this is a 230 volt pump. We're going to set this 230 volt pump inside the reservoir tank, but before we do that, we need to tether this float switch to the pump itself. This is a normally open float switch that will turn this pump off if the reservoir tank gets low. This is a low water cutoff float switch. It's important for protecting this pump. But we can't leave it like this because that's too large of a swing on the float switch. We want to tighten this tethering up so that the swing is only that large instead of this large. In order to do that, we're going to use the zip tie that's included with the pump. We're going to zip tie it to the pump body, leaving approximately 4 or 5 inches of cord between the tether point and the float switch itself. Once we do that, we have this cable. This cable for a 230 volt motor or for a 115 volt motor, it's going to have a black lead, a white lead, and a ground. If you're getting the 230 volt model like this one, the black and the white are both hot legs. If you're getting the 115 volt model, the black is your hot, the white is your neutral, the green is always the ground. To plumb this pump up, it comes with 1¼ inch stainless steel threading on the top of the pump, and that's female threads. Again, we're going to use Schedule 40 PVC or Schedule 80 PVC, and we're going to put in 1¼ inch male by 1 inch PVC adapter. Use some Teflon tape. Do 3 to 4 wraps of Teflon tape in a clockwise manner. And then we would hand tighten this, making sure that there's no cross threading. Hand tighten this into the top of the pump. After which point, we take a pipe wrench here and another one here to tighten that further. Then, we're going to install a union, PVC union. This is glue by glue. And we're going to put this union inside the tank so that if we ever need to service this pump, we can simply disconnect this union, which will allow the pump to be pulled out of the tank. We want this union to be fully inside the pump, or inside the tank rather, and we want this collar to be on the top half of it when we're gluing this all together. If we put it like this, when you undo the union, this collar will slip down, slide down over the pump and into the tank. Then it's a bear to fish out. So you want this collar on the top half of the tank so there's no place for that to fall. So we're going to simply measure up about 11 inches, and we're going to cut PVC 11 inches tall. And then again, this is for a 250 gallon tank. Oh, I'm sorry, 300 gallon tank. We have our 11-inch piece. Of course, at this point, we would put primer on, let it dry, put cement on, and then use PVC cement to secure that pipe connection. We would do the same thing with this bottom half of the union. PVC glue that in. And then at this point, we're going to cut another piece that will go down through this gasket. To make it easy on yourself, again, you can file this down so that it's angled. Put a little dish soap or our pipe penetration gasket lubricant on the end of it. And then use a mallet to pound that in. Now, we're going to set this pump up on the inside of the reservoir tank. We're going to note that we want to make sure when we're installing this pump, we don't want to install it so close to the wall that this float switch gets hung up on the side of the wall. We want to make sure it's somewhat centered, or that the float switch is angled to the biggest cavity in the tank so that it doesn't get hung up on anything. So we're going to set this in. We're going to leave this cable out for now. We're going to pound it down till it's nearly touching, and then at this point we would PVC prime and cement the top part of the union onto this pipe. Let that glue set up for a bit, and then hit it down until the union is touching completely. At that point, you can hand tighten the collar and then come in after and use some channel locks to tighten it all the way so that union is nice and watertight. We'll leave this cord out for now, and we now have a stub out, and we're going to carry this pipe all the way back down and into the pressure tank. So now, instead of that well pump feeding the pressure tank, our reservoir pump is going to feed the pressure tank to supply the house. So this is what's going to generate your household water pressure. Okay, so now we're going to plumb this pump into the pressure tank. Now in this case, the pressure tank T is tapped with 1-inch male threads. So we would wrap our Teflon tape on there. Give it 3 to 4 wraps. And then we're going to attach a 1-inch female by PVC adapter. This would be glued in. Now, running metal threading into a PVC female thread is not ideal, as I mentioned before, but when you work on plumbing long enough, you know the threshold and the tolerance, and you can gauge pretty easily where the break point is. Just don't thread it all the way into that female adapter and you'll be fine. We have that in place. We would glue in a 1-inch 90, PVC 90 to bend that up. At that point, we would come in, glue our 1-inch PVC pipe, into the 90. We would glue this 90 in place. It always helps to dry fit everything before you glue it. We get a measurement here, making sure everything is nice angles. We run that pipe, and then finally we would glue this last 90 into the top of the PVC here. And of course, if this were an actual install, we would make sure we got our angles exactly right to get it nice and looking pretty. But since this pipe is not fixed, it's hard to do. And now, of course, here's the principle. Our new reservoir tank pump is pressurizing the water, sending it back into the pressure tank to supply the house. So now we need to wire this pump into the pressure switch. Now, in order to get the cabling and power supply from the pump out of the tank, there's a couple different methods to do that. First thing we need to note is that there's ultimately going to be two cables coming out of this tank. The one for the float switch, the one for the pump. So we do, as I mentioned before, include a third 1-inch pipe penetration gasket. This could be used to put 1-inch conduit through to run those two cables out of the tank. And you could do that at any location on top of the tank. It should run out the top. The other option is to use what's called a cord grip connector. This is a fitting that, as you tighten it down, so you would thread this into the top of the tank, drilling a hole that's this thread size, thread it into the top of the tank, run the cabling through there, and then tighten this down, and as you do so, it tightens against the cabling insulation to create a nice firm connection point. My preferred method is to use the 1-inch tank penetration gasket. I will put this in. I'm actually going to put it in the opposite side of the tank. I know it's counterintuitive. I'm going to put it in the opposite side of the tank as the pump, because this is where this float switch is going to tether in the tank. And again, because this float switch swings, we want it to be as unobstructed as possible. So we want it in the center of this cavity right here, so that it can swing to the side and not get hung up on the tank wall. So that's where I'm going to drill my hole for the conduit penetration. We'll pop this gasket into place, flange side out. Then we will use some 1-inch conduit to run out of the tank. And my apologies, but I did not bring 1-inch conduit for this video, so I'm going to use 1-inch PVC. It's the same diameter, it's just a different color pipe. Again, I'm going to use the rubber mallet. And then here you could mount a junction box or some sort of electrical box, or run hard conduit to your destination point. There's several different ways to approach that. For brevity's sake, I'm just going to run the cable straight up through it. So this is the cable for the pump. And you want enough slack in here so that it's not going to interfere with the float switch. And then I'm also going to run the float switch cable up and out of this stub out. We'll leave that loose for now. Now the alternative is that you can have two different penetration points, one just for the float switch and another just for the pump cable to wire into the pressure switch. Now, if I was doing this in an actual install in someone's house, I would run a conduit connection point with some flexible conduit to a junction box, run these two cables to a junction box, making sure that I know which supplies which, and a telltale sign is the float switch only has 2 wires, the pump has 3 conductors. We would run it to a junction box and then extend out of the junction box, one to the pressure switch and another to the pump saver. Since this is just for demonstration purposes, I'm going to do an alternate route for this cable, and I'm going to take the pump cable out of this, and I'm going to instead use this clamp down cable connection fitting. I'm going to drill it right here. Then I'm going to loosen this, grab my pump cable, which again has the 2 conductors in the ground, run this cable up through the hole, up through this connector and through the gland, expansion gland. And then it allows me to run my pump cable along the pipe and into the pressure switch. Strip the wires. And then run it into the pressure switch. Again, ordinarily this would go in conduit. This is just for demonstration purposes so we can show the basic wiring. We would wire this into the box. Since this is 230 volt, it doesn't matter on the leads, but we're going to stick, they're both, the black and white are both hot. So the white wire could technically get matched here, but the easiest thing to do is just stick with the same color combination. So the black and black are going to be on the left side here. The white and white are going to be on this right side. And then we have our ground, which is going to go to the green grounding screw found in the pressure switch. Again, make sure the power is turned off to this pressure switch. The breaker is turned off. We clamp this down. If you have a clamp connector here, we would tape this up to the pipe, or actually run it in conduit. And now we have our pressure switch wired up to the new pump. Again, you want to make sure that the voltage that's supplied from this breaker that's supplying this pressure switch matches that pump voltage. In this case, we put a 230 volt pump in there, so we want to make sure this is a 230 volt breaker supplying this pressure switch. We would cover this up. And we're not going to turn that circuit on until we have the well pump starting to feed the tank. Okay, now we're going to tether our normally closed float switch. Once again, this is the switch that controls the well pump to tell the pump if the tank is full. In order to do that, we are going to release this clip on the tether. We're going to pick a tether point for the switch, and again, we want about 4 to 6 inches of cord between the tether point and the ball float itself, so we can keep that swing nice and tight. So we insert this cord into the cable weight, and then we simply press this clip in. You can see it clicking. Press it in, and it locks that cable to the cable weight so that this is suspended and this can just freely float and tether in the tank. So what we do here is we're going to pick our point. Generally speaking, we're going to have this cable weight about 6 inches from the top of the tank, and we want to make sure that when this float switch clicks in the upward position, right there, that it's not, that the top of the tank isn't stopping it from clicking. So for instance, if we have it too high, the float switch can never get to that cutoff point. It's always going to bump up against the top of the tank. So we want it down a bit, right about there. And we're going to loop this. And for now, we're just going to tape this to the conduit so it can hold that height in the tank. That's our temporary setup until we figure out our conduit situation, what kind of conduit we'll want to run. You always want to check with the local electrical code to make sure that you're code compliant with your electrical connections. Now this end of the float switch is now going to run into our pump saver box. Our next step is going to be mounting the little fused pump saver so that it can now control the well pump. Because again, before the well pump was being controlled solely by that pressure switch to tell the pump to turn on and off. Now we disconnected the well pump cable from that pressure switch, so now there's no power going to the well pump, nothing to turn it on. So we need to wire this into the little fused pump saver. We're also going to wire in the normally closed float switch into this pump saver, and we're going to pick a mounting location that's convenient for the amount of cable that we have after we disconnected the well pump from the pressure switch. So this would be a good spot. If this were a real installation, this would be a good spot on the wall to run this cable in to the pump saver. This would go, if we take the box off, the well pump would be wired to the L1 and L2 out on the pump saver. And then we would have to run a new dedicated circuit from the breaker panel to supply power to the well pump, matching the voltage of the well pump. So if we have a 230 volt well pump, we need to make sure that's a 230 volt breaker, and we would supply power to the inside L1 in, L2 in from the breaker panel to this box. I have a detailed video just on wiring the pump saver that I have a link to below. I'm going to go into more detail in that video than I will here. This is just a basic flow of operation for the system. So we would mount this box, wire our well pump into the box, into the outside, L1 out, L2 out, bring a new breaker, new dedicated circuit to the L1 in, L2 in on the box, and then interrupt one of those legs with the float switch. Now, I will note that some well pumps are what are called 3-wire well pumps. A 3-wire well pump, it means that the pump has an external start capacitor. And if you have a 3-wire well pump, you're going to have a control box already mounted on your wall somewhere. So the well pump wiring will go from that pressure switch to the control box and then out to the well pump. If you have something that's marked control box and you open it up and you see a capacitor in there, you want to make sure that you put this pump saver in. You want to install it between your electrical panel and the control box. So you would go electrical panel, pump saver, control box, then out to the well pump. Make sure, that's a very important detail, because that control box will send another wire out to the pump, and if you try to mount this in between there, it's going to mess everything up. You won't be able to do it. So this has to go between the electrical panel and the control box. Most well pumps are 2-wire well pumps that do not have an external control box, so it'll be just well pump to pressure switch to panel. So if you have a 2-wire well pump, you can mount this anywhere between the electrical panel and the well pump, including even outside if you wanted to. This is in a NEMA 3R box. It's a weather-tight box, so this can be mounted outside by the well if you want to do it that way. After you mount that pump saver, then the float switch is going to tell the pump whether there's water in the tank or not, and the pump saver is going to monitor if that well pump has water in the well to be able to pump. So it has a number of different ways that it's going to shut the well down if it's in a dry run condition. I just want to also mention that occasionally we'll have customers call in and say, hey, do I need a pump saver? I have something called a pump tech already installed. Does that do the same thing? The answer is yes and no. A pump tech is a pump saving device that will shut the pump down if the well pump starts drawing air. However, this is manufactured by Franklin Electric, and I've heard from numerous Franklin Electric reps that this only works with certain Franklin Electric motors. It does not work universally. It will not work with a Pentec motor. It won't work with our Springer Series motor. It won't work with, any number of Myers or Goulds, any of those types of pumps. So if you have a pump tech, make sure you have a Franklin Electric motor in your well already. And if you do, great news, this will work and you don't have to get our pump saver. But if you have a different type of pump, you will want to switch this out for a pump saver. Now, the very last thing in installing a well reservoir system is considering an overflow for your tank. Now, I mentioned at the beginning that the ideal location for this reservoir is adjacent to a floor drain. The reason for that is you may want to consider getting another pipe penetration gasket, a 1-inch pipe penetration gasket, and installing it in the side of this tank and putting PVC into the side of the tank and running it to the floor drain. That way, if this float switch ever failed and the well pump just kept pumping in, which it can happen. I haven't seen it happen, but it's a mechanical switch, so it certainly can happen at some point. Hopefully not for 30 years, but it could happen. If that float switch fails, you want a safeguard to make sure that the tank is not just overflowing in your basement. So the best way to do that is just to drill out a hole, put in a pipe penetration gasket, run PVC to a floor drain. If you don't have a floor drain, I'm going to link below to a detailed video on how we install a makeshift overflow flood prevention technique using our WellStop Water Pro and a 5-gallon bucket. It's a great way to makeshift an overflow if you don't have a floor drain. Thank you so much for watching. I hope this has been helpful. Again, I'm Jonathan from Rain Brothers. We have all these supplies we try to keep our costs down as low as we can. We really try to serve our customers. We're a small company and hopefully we earn your business. And thank you so much for watching.